All right, so when we're looking at this problem, this is kind of a complex looking problem, but once you kind of see it, it's not so bad. When you see a problem like this, I want you to think if you can factor out the top. If you can factor something out of the top, then maybe the bottom denominator will go away. Is there anything you can take out of all three? I could take a 2 out, not here. And really that would be the one that you want to take out is a 2 because then you can get rid of this 2. I can take x's, no x. If I put this in a box to factor it, this is an x cubed and an x. And we usually do that when we have an x squared. We can try it, but it's not going very far because of this x cubed. So here's what you do. When you have the division, and this is a division problem, the top divided by 2, you can break it up. So it is 4x to the third divided by 2 plus 6x divided by 2 minus 5 divided by 2. Now, 4 divided by 2 gives me 2x to the third. And again, if it helps you, 2 divided by 2 would be 1. 4 divided by 2 would be 2. 6 divided by 2 is 3x. And we can't divide the 5. And that would be our answer. We can't do a factoring situation to get rid of it, and that's where it's left us with. Now let's see if we can factor this one. There's a 2, a 6, and a 4. I can take a 2 out of all of them. This one has 3 x's, 2 x's, 1 x. I think I can factor something out. And I think I can factor a 2x out of each. So this is going to be 2x times, well, I got a 2 and 1x. I need 3 x's, so 2 more. Plus 2x times, I've got a 2 and I need a 6, so 2 times 3 is 6. X squared, and I've got 1x, so x. And then 2x times, 2 times 2 gives me 4, and I've already got the x. So if I take that 2x out and set it off to the side, 2x, 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 I'm left with x squared plus 3x plus 2 over, because all of this here was over the number 2x. This is two terms, or two sections. If they're separated by multiplication, we can simplify. And 2x divided by 2x is 1. And I'm left with x squared plus 3x plus 2 as my answer. So now this one's a little bit more difficult. We're looking at this. Now if you look in the book, they actually start dividing it right here, and we're going to start with factoring first, and then in the next problem you're going to see how to divide because of the fact that we can't factor that one. This one we could actually factor. How do I know that, or how would you know that? Well, let's look at this. This divided by this. Okay, I'm looking here. If I can factor this, maybe I can do something. So I'm going to put it in a box. And when I look at the numbers, before I start putting it in a box, I look at the numbers and I think, okay, can I factor it? And I'm going to look here and say, is there a number that I can multiply together, 2 of them, to get 6, but then when I add them together, I can get 5? And I say, yes, there is. So I'm going to try putting it in a box. That's how I always try to start it, is asking myself that question. Can I multiply 2 things together and get 6 and add the 2 and get 5? So 3 and 2, when I multiply them together, I get 6. When I add them, I get 5. So let's see what happens. 2 and 2. These 2 share the x. These 2 share the x. And these 2 share the 3. Here I get a 2x and a 3x, and 3 and 2 does make 5. So if I factor these, I get x plus 2, and I know it's plus because it's positive, and x plus 2. Or excuse me, x plus 3, because it's positive here, x plus 2 here. Divided by the whole thing divided by x plus 2. Now I can rewrite that as a fraction like this. That's what a fraction bar means. A fraction bar means division. And again, I can take these two and go x plus 2 divided by x plus 2 is 1, and I'm left with x plus 3 as my final answer because it is a multiplication there. All right, so now we're going to do this with division. This is not a very simple thing to do. It does take a little bit of effort. So let's set this up in an actual division problem, and this is going to look weird. First number divided by the second number. So literally we're going to write it in to a division problem. When we do that, we're going to say to ourselves, can we take x minus 3 and divide it into x squared? And we can't. But we could do it here. And we're going to do that by multiplying by x. And watch how we do this. X times negative 3 would be negative 3x, and x times x would be x squared. I'm going to take this and I'm going to subtract it from here. X squared minus the x squared, and you might have to distribute that negative because that means then this is going to be minus and this is going to be plus. So x squared minus the x squared would give me 0. 2 plus 3 would give me 5x minus 12. I say, okay, in order to get that x to be 5x, I'm going to do plus 5. 5 times 3 is negative 15. 5 times x is 5x. I need to subtract it, distribute the negative. Negative times the 5x, negative times the negative 15. Here, when I add those together, I get the answer of 3. Here I get the 0. I can't do anything else. So this is where it gets kind of weird as far as plus the remainder, and this is from way back when you started learning division. You take this number divided by this, 3 over x minus 3. And that is our answer. Now what I'm trying to talk to about is, let's look at a regular division problem to see how that would look in regular division. If we said 17 divided by 3. Well, 3 goes into 11 or into 17 5 times. Subtract. And we get the remainder of 2. And if we were going to write this, we would put it up here and we'd say 5 and 2 over 3. And really we added them together, but we don't put a plus there. So when we're doing it here, we're saying, well, we can't just kind of cram it on with the 5. We add it on, and it's this number divided by this number, just like we did here, 2 divided by 3. So again, we're going to set it up under the division bar. X plus 1 in the front, this number divided by this one. When we write it out, we got to put in some holes for x squared and x since they aren't there. So we say plus 0x squared because 0 times x squared would be 0. So we're adding 0 here. And 0x, so again we're adding 0 here, plus the 1. So these two were missing here, but in order for the division to work, you have to have a place for all of them. So now, x times x squared is going to give me x to the third. So I'm going to put that x squared up here. X squared times 1 would be x squared. X squared times x is x to the third. We're going to subtract it, distribute the negative, minus and the minus, and so I distribute it and it's gone out of here. This gives me 0, and I'm left with a minus x squared. Bring down the plus 0x. From here and to here, to get this x to this negative x squared, I need to do a minus x, because negative x times positive x is going to give me a minus x squared. Negative x times a positive 1 gives me a negative x. I'm going to subtract that, because that's what we do when we divide. Distribute that negative. This becomes positive. And here, negative and a positive x squared makes 0. And 0x plus a positive x is going to give me an x. Bring down the 1. And now look, x plus 1 divided by would become x plus 1 if I multiplied by 1. And 1 times x plus 1, boom. Subtract, distribute the negative. This gets a negative and this gets a negative. X minus x is 0. 1 minus 1 is 0. And we get this as our final answer. It's not easy, but it's not the most difficult thing that you can do. So you need to understand that this is very basically a formula kind of thing. Try it, and when you give it a chance, and if you're still struggling, please make sure you ask me for help.